Thanks, Guy. I'm happy to be here, and thank you to be here for this talk about like how can you do like log ingestion fast. I'm Nicolas Frankel. I have been a developer. How many developers are in this room? Oh, still a few hands. Okay, I was thinking a lot of you people would be like ops teams, but that's great. I've been a developer architect in the Java ecosystem for a long time, but 6 months ago I decided to change my career and thought that it would be much better to be paid to like go to conferences, meet people, have beers. That's a good way to be paid. Huh? Even earlier on, I was always interested in the other side of the wall, you know, where basically you throw software at and you hope people somehow manage it. So I guess I'm pretty like DevOps minded. I work for a company called Exoscale, and at Exascale we are actually providing you with like cloud computing and cloud storage services. Who here is already using the cloud in production? Well, a few hands, third of the room. Who is using Amazon? Okay, who is using Google? Microsoft? Exascale? That's what I thought. Guys, do you know about the Cloud Act? Who knows about the Cloud Act? No, 1, 2 people, 3 people, and not probably those that are using the cloud. The Cloud Act is a US law, and it's an extraterritorial law, which means that it applies outside of the US, which is very funny, like GDPR. And actually, it states that if you are contracting with an American company, that means that legally the government, the US government, can access the data center wherever it's located in the world. It shines a new light to your use of the cloud. I know it's not your problem, but if you are working for a company that handles data and that customer give like this data to the company, trusting them to handle it, can create a lot of issues. I would really recommend that you like go to your legal department, check about the Cloud Act, and probably change to like a European cloud provider. We are not the only one, we are one of them, but be very careful about that. Okay, back to log management. Who can not understand this stuff? This is what you do, even if you are not a developer, this is what you do generally, right? You do a debug. This is Java. Who here doesn't understand Java at all? Okay, what's your preferred language? No language. You are agnostic. Okay. Python, okay. Python, it will be hard for me because I don't know Python, but okay. This is a debug statement, and basically you have like the string and you have the computation, right? This is what you expect to have in your logs, is card price will be something. This is what developers generally do, and they are blissfully unaware of how it works. Because what they believe is that here I have a debug. So what happens if my log level is above debug is it will be ignored. Who thinks the same? Yeah, that's normal. However, it's not the case. And I have a little program that does it. So I've created the logger with SLF4G, blah, blah, blah. I mean, the important part is this one. I have this logger.debug, and then I have my message. And then I check how long it will like be for me to log this. Everybody agrees with that? Yeah, no issues? Just tell me. Really, if something is not fine, let's discuss it. Five seconds. Took me 5 seconds to run that. And if I check the default stuff, I'm info level, so I'm above debug. So debug statement, and actually it's the case. The debug statement was never written, but it took me 5 seconds. Who can tell me why? Yeah, don't be shy, no worries. I say a lot of crap myself. Yeah, sure. Perfect. So here, I've been working in e-commerce. When you compute the price of a cart, it's not it's a value because you need to apply the discount. You need to know who is logged in. I mean, there are a lot of computation. Here, I simulate a long computation. The computation takes time, and it's not guarded by the debug. It's not guarded at all by the debug, actually. So whatever your logs are doing, if you are doing computation inside of the logging, it will slow you down. So how do we handle that? This is how we handle that. I put a guard myself. If logger is debug enabled, then blah, blah, blah. In that case, since the logger is only info, then it's not debug enabled, and then what is inside the block won't get executed, right? Let's try it, just to be sure. No, 2. Instant. Everybody agrees with that? So if you are a developer, that's what you are meant to do. Every time. With no error. Like, hey, what happens if I do that? Because, I mean, we are only human beings. It can happen. If every time you need to write a log statement, you need to guard it, then you need to, like, be sure that it's in sync. Probably it won't be in sync. Yeah. Yeah, then you are back to the square one, because actually, yeah, you are one enabled, but it will be, of course, it's not the only stuff that you can do. You can do the opposite. And then you lost a log at all. So this is the kind of stuff that might happen if you do it like that. But we can do better. Actually, sorry. Since Java 8 and already languages like Python or JavaScript allow it since ages, you don't need to pass the computation result to a log statement. You just need to pass the computation itself. So what you could do is you could write a lazy logger that wraps a logger, and instead of accepting the result of the computation, accept a computation. And then inside, you can guard it, and then only then, if it's debug enabled, then you call the computation and you execute the computation. And if you call it in Java, it's not super nice. In other languages, it's a bit nicer. So you can have this kind of like notation. And if I execute that, it's not as good as the no op stuff, but it's still pretty good. And with 0 risk of errors. So you just had the main logger API, and you just provide the lazy logger API. That's the first lesson. So it starts from the developer point of view. You should only do lazy logging. Second point. Developers, they don't like to think about it, but actually we are dealing with the physical world. We are dealing with hard drive. And when you log, in general, you are writing something to a file. And now it depends where your file is located. If your file system is implemented on a SSD, it might be very fast. On the standard hard drive, it might be slower. On the network file system, definitely it's going to be shit. So on one side, you have the developer world, and everything is fine, and it needs to do stuff. On the other side, you have the ops world, the infra world, and you also need, as an infra guy, to handle that. However, we can cope with that. In general, what your logging framework does, and so we get back to the developer world, is you open the stream, you write bytes, you close the stream. Opening the stream takes time. And you do it for every log statement. You open the stream, you write the byte, close the stream. You open the, well, you understood. It could be very great if we could open the stream, write many log statements, and then close the stream. And that's all asynchronous logging. And it's not a developer problem. It's not like an infrastructure problem. It just sits somewhere in the middle. I don't know if you have those kind of people who are called integrators or configurators or whatever. They are the one who configure the software in every environment. And they are the one that should do that. By default, you do synchronous logging, but most frameworks, they allow you to do asynchronous logging. Here I have a framework called Logback. And this is how I do asynchronous logging. So instead of writing directly to the file, I just wrap my, well, it's not, here it shouldn't be std out, it should be file, sorry. I just wrap the stuff into an async appender, and I'm using the async appender to write it down. It's not very interesting, the running of that stuff, but you understand it. Shit. However, now you start, if you start doing asynchronous logging, then you need to understand how it works, basically, because then there will be a queue of logging statements. And the queue, again, we are bound to the physical world, we are bound to memory. It must have a size. Yeah, it's always a problem of trade-offs and of thinking. So you need to configure the queue size. And sometimes you might think, okay, but my queue starts like being nearly complete. What is better? I keep every message. And when my queue is full, I start discarding them. Or when my queue starts being full, then I discard the log levels that are below a certain threshold. Because the error messages, they are much more important than the debug messages. So Logback allows you to do that, to say, hey, you can discard when your queue is, let's say, 80% full, you can start discarding because those log messages are much more important than debug statements. And then there is this issue of reliability. What is better? To actually lose log message because your queue is full, or to write them anyway and then start blocking again? It's up to you. It depends, exactly. I've been a consultant. The answer, it depends, yes? Yeah, so what the gentleman says, yeah, if you are using asynchronous logging, then you have no reliability, because if your program crashes for any reason, then your JVM or your JavaScript engine or whatever goes down, you lose everything in memory. Okay, next point. The log message is not the most important stuff. It's worth nothing if you don't get metadata associated with it. One of the most important metadata that you need to have is a timestamp. Yeah, I mean, it's stupid, but it needs just to be told again. Log level is also an important metadata, because afterwards you might need to search through all, I don't know, like error statements, thread name, class name, whatever, you name it. You can have a lot of metadata that is associated with every log statement. Some of them are very expensive to get. You can have, like, Logback allows you to have the line number associated. So basically, you can trace a log statement to a line number in your source code, which is very, very cool. And a lot of developers might want to have that, because, yeah, I mean, what's better than to debug in production? But actually, again, there is a trade-off, like, it's easier to debug afterwards, but then getting this line number is a very expensive operation. And then if you need to do it at every log statement, it will slow down your logs a lot. So what we can do is, you can still have the line number, but you cannot, you shouldn't compute it. You can write it explicitly in your log message. And then we get back to the problem that it might give you wrong advice if you write it explicitly. If you just have a bunch of logs, especially nowadays where you might have like 10,000 of instances, it's completely useless. It reminds me a story where I was working for a public administration and they had backup in place. They had a process to do backup. They did the backup every week or every day. Once we needed to access the backup, we couldn't restore it, because they never tried that actually the restore process was working. So if you just store your logs somewhere, it's fine, but in general, that's not very useful. What you want to do is you want to aggregate the logs in a centralized place, and you need to search for them. You need to query them. And you might know about Elasticsearch, you might know about Splunk, you might know about Greylog. Those are all great products. And in those products, in general, you add additional metadata. The file, because probably you don't have a single log file, you have multiple log files. It might be like your web server file, your application server file, whatever. The host the log comes from is super important. And if you are using the cloud, the zone might be important. Also, the environments, that you have like dedicated tags for each of your environments, whether it's development, it's staging, it's pre-production, is important. Those are like required metadata. And so, when you aggregate those logs, you might want to search with those metadata in mind. Like, find me all the production logs that are like Java related. And so comes the issue. When do you actually index the logs? Because Elasticsearch, which I happen to be most familiar with, is a NoSQL data store. And as you know, NoSQL data store, they don't have any schema. Yeah, that was a joke, sorry. I was not clear enough. Of course, every data store has a schema. The thing is, The good side is that you don't need to like think about it beforehand. You can let Elasticsearch, you send your documents, and then by default, it will try to be smart with the JSON and actually create a schema out of it, or just like augment the existing schema. And if you want to be very, very fast, then you just send like queries. You don't think about the schema, you let Elasticsearch does its magical stuff. And when you query, it's going to take a lot of time because actually you don't know what the schema will be, if it will be consistent or not, and you will need to handle all that crap. And if something that you wanted to be structured is unstructured, that means that you will revert to do like a select from like something, which is like very, very bad. And that's the time when you will need to be fast. So actually, either you ingest your logs very, very fast, and then when you query, it's going to be super slow, or you accept that when you send the logs, it's at the time that you index, it's going to be slower. But when you actually need to query, then it's going to be much faster. It can be seen as a trade-off, but to be honest, in my opinion, there is no real choice. But I mean, it's up to you. And again, I'm more familiar with the Elastic Stack, so I will talk about the Elastic Stack architecture. So you have file beats that like reads the log files and then sends it to Logstash, and Logstash can already like try to process it and then sends it into like a JSON format to Elasticsearch. Who is familiar with Elasticsearch? Well, nearly everyone. Okay, that's fine. So this is the general like architecture. Yeah, you've seen that I was an architect. I can do like UML diagrams. Huh? It's a good sign. And everything here works because it's on the dash on the whiteboard. That's very fine. Really, I'm not joking. It works very well. So first you have the creation time. So the application produces a log on the file. And then you have the ingestion time where FileBeat will read the file, get the log, and send the log to Logstash. And the Logstash will transform the log into JSON, and then will send JSON to Elasticsearch. So this is the general workflow. Who here has already been using Logstash for real? Yeah, again, like more than half the room. Logstash is written in Ruby. When you think about Ruby, do you think this is the most performant part of your infrastructure? I'm not a Ruby developer, so I troll a lot, but it's not really wrong. And so Logstash is super good, so you send it this kind of stuff, then you have this like Grog Pattern, and then it spits you out this JSON. Of course, you need to write the Grog Pattern, and I mean, creating the Grog Pattern is a skill in itself. Right? It's not super fun most of the time. However, once you get it, it's quite convenient. But the problem is it takes time. And if you are using the Elasticsearch, the Elastic Stack in production, then Logstash might be one of like your congestion nodes. Then you need to scale it, and it's not super great. But when you think about it, who told you that you needed Logstash at all? You need Logstash to do the grogging for you. But why can't you produce JSON directly? Actually, it will make the log harder to read on the server. But really, are you really connecting to the server and reading the log there? Most people don't do that anymore. So you can directly create the JSON yourself, like that. And guess what? it's the same like stuff. I didn't use async or whatever because it's just not my point here. But I can, with the log statements, directly have the JSON. It just needs a default like templating that is a bit different than what you expect. But basically the pattern itself, you can create it in JSON directly. Oh, one of the gentlemen is super unhappy here. Now I'm afraid. What did I say?
Why is your date not an ISO timestamp?
If you have some time, I can check on the internet and then check it, how I can produce it. But probably here it's because I use this pattern. Because the pattern I used, again, I used before, not an ISO timestamp. Yeah. Believe me, you can do whatever you want. You can actually, I have the date and I have the time. I separated them, but actually it's because, well, the reason is I didn't want to, I'm a dry kind of guy, so I don't repeat myself. And actually, yeah, don't repeat yourself, it's dry, right? It's because this is what is produced and what afterwards, like Logstash produces out of it. So you have the date itself, but then you can also have like, again, duplicated information that are indexed themselves. It depends. You can choose a pattern that rocks your boat. But it's a good question. So now, we are much faster because FileBit is super fast. And Elasticsearch can be scaled up to your hot content. And you don't have this like Logstash stuff in between that just sits there to do the parsing. And that's pretty crazy. You create like a string and you transform it into JSON. Whereas you can just create JSON. There are two stuff that I also want to mention. First is log files. Really? If you are using Docker, you know that you don't need to actually produce log files. You can just change the driver to send events. So what I told you about where you write your file, your log on, doesn't apply anymore. It's only networking and memory, much faster. But then, if something happens, then we get back to the problem that everything is lost. Second is, I told you some metadata is hard to get and is expensive. But when you miss it, then you feel naked. In that case, I would advise you to think about like hot reloads for your logging framework. Because then by default, it can be very fast, and then you just change the configuration on the fly, and because of the hot reloading feature, then it will get slower, but when you have a problem, at least you will have the metadata that you need. Those are things to consider. So at Exoscale, how do we log? We don't use FileBit, we use syslog-ng, and we have Kafka in the middle, although we just spits out JSON. This is our architecture. And the reason is, why? You just told us that it's just like FileBit, Elasticstack, and then no Logstash, and then you put Kafka in the middle. True. So the reason for that is we have syslog because basically when we started that, then FileBit was not that production ready. So why change? I mean, you know, if it works, don't touch it. So we still keep syslog-ng. Besides, our infra guys, they are much more used to this kind of stuff. So for them, it's more natural than learning another tool, FileBeat. And then we'll send stuff to Kafka in between. Before sending them to Elasticsearch, we send them to Kafka. And because Kafka is just a data store, we need something to get the stuff out of Kafka and send it to Elasticsearch. That is the job of Logstash. In that case, Logstash doesn't transform anything, but it's just like, you know, an EL, not an ETL because it doesn't transform, but an EL. Huh? You just take and put, take and put. So why do we send the stuff to Kafka? We have two reasons for that. So, like historically, Elasticsearch was not like super reliable, and sometimes you needed to do stuff. Like restart it, and if you just send your stuff to Elasticsearch during the time when it reloads, basically, then all your edge nodes, they start buffering the logs, and so your whole data center starts getting trouble. Like the memory consumption is huge, and it's better to have this centralized stuff. Another reason for that is we are doing like complex event processing, so basically the billing of the data center is made, well, the data must be centralized in Kafka. So it's better to have like one single point where every event is aggregated, and so we are just sending everything in Kafka, even if it doesn't matter in the billing or in other like business decisions. So this is a summary. First, if you are a developer, you don't pass the result of the computation to the logging framework. You just pass the computation itself, and then you have a centralized point where you guard with the log level. The second is if you are an integrator, if you are an infrastructure guy, well, you need to consider where you are logging to, what like Vorlog maps to in the real world. Third is if speed is more important than reliability, then consider going asynchronous. And even in that case, where like you can consider still reliability, you can still go asynchronous and then configure your logging framework to skip events if they are of like a certain level, below a certain level. Don't use expensive metadata, and that's every logging framework tells you this is expensive metadata to get, so don't use them. But in case you need them at some point, then think about hot reloading. Again, you lose a bit of performance because you have a thread that runs in the background that watches the configuration file, but it's just in case. No alternative, yes, schema on write is slower, but actually when you search, which is basically what you really want, it's going to be much faster. So in that case, that's not really the trade-off, but if you really want to be fast, then go that way, but afterwards your search will be like crawling. And then, of course, don't transform your logs, just send the result that you want to whatever. Like if you are using Elasticsearch, then send JSON directly, or I don't know how Greylang or Splunk work, but probably they might be the same. Just send what your centralized logging pattern expects. Might be stupid to say it, but if you want very fast logs, then it's everyone's responsibility. The developer, of course, because he's the one producing the logs, but also the ops guy, the architect. Everybody must be involved. That's cross-cutting concern that cuts across all organizations. And of course, it depends. You can be very, very fast. You know, if you want to be very, very fast, you have no monitoring because it's just like slows you down. Really. When I had talks about some monitoring tools, the question was, but how less performant will my system be? So the answer is it better to get fast blindfolded or to just slow down a bit and to know where you drive? So the speed in itself is not very important. The question is, what do you want? Do you want a reliable system? If you are sending logs to bill your customer, you must be pretty sure those are like transactional. You cannot just send like bad billings to your customer in one way or another. It's not good. So of course you want to be fast, but consider what trade-offs you need to trade them for. So thanks for your attention. You can read more about my blog, which is more like programming stuff. The DevOps stuff is written on my company's blog, and you can follow me on Twitter. And now I guess we have some time for questions. Thank you.
Yeah, questions.
Thank you.
Hi, sorry. The last slide with your whole pipeline, you had Kafka going into Elasticsearch. Did you say that there's Logstash in between, or?
Look, well, actually, it's a UML diagram sequence, so it must always be on left to right. The arrow must be on left to right. So yes, I have Logstash in between, but it must sit there because Logstash will read stuff from Kafka and send it to Elasticsearch.
Right.
No one ever in the history of the world has ever understood UML diagram.
I do.
Okay, then follow up. In your experience, which is the most fragile part of this? Like what has failed most often?
Well, regarding the context of Exoscale, this was Elasticsearch that was failing most of the time. That's putting Kafka in the middle actually increased the reliability of the whole system.
And it was the restarts? Or what caused Elasticsearch to
you know that Elasticsearch is based on the JVM, and at some point, I don't know if it was misconfigured or whatever, but we had like stopped the words events. So basically, when Elasticsearch like tries to do like the garbage collection, it might run for like 10 seconds, 20 seconds, whatever. And again, when you are in this state, then Firebit cannot send the events, then the load on every H node increases and blah, blah, blah. So Kafka, in that case, helped us a lot.
Cool, thanks.
Thanks.
More questions?
When there are no questions, that means either two things. I've been extremely clear, that was the best presentation ever, or it's the crap of the day, and you will always remember it as well. So I'm a bit afraid of the second option. It was the first time I did this talk. I would be very, very grateful if you like sent me, or I don't know if there will be feedback forms or whatever.
Yeah, will be.
Okay, if you like not only graded me, because grades, especially if it's a good grade, it's always nice, but especially if you like wrote in the comments what stuff were not clear, what you dislike, what could be improved, because then for the next session I could perhaps improve a bit. Thank you very much then.
Thanks again.